Hello students, welcome back to online physics lesson. Today we will see acceleration. Let's define what's acceleration. Acceleration is a vector physical quantity defined as the rate at which an object changes its velocity. The rate means here the time that an object changes with its velocity. An object accelerating if it is changing velocity. If we say an object or a car or a plane accelerated, there should be a change in velocity. There should be change in velocity. In general, the acceleration is the rate at which the velocity changes. That means acceleration is given by this formula. That means the change in velocity by the change in time, which is equal to v final minus v initial over t final minus t initial. Where that means here v final minus v velocity final minus velocity initial over time final minus time initial. And because acceleration here is in meter per second, that means the SI unit of acceleration is meter per second square. It's SI unit here, it's meter per second square. That means, for example, here the change velocity means the unit of velocity is meter per second over the time unit is in second. That means in your mathematics, meter over second, which is equal to, in your mathematics, if there is over, we multiply by reciprocal. That means a meter over second times this one comes, which is equal to meter over second. S times s second. So that's why we say the SI unit of acceleration is meter per second square. Let me show you one simulation. Okay. All right, here we go. Here are three cars. Okay. Here the first, the red, this one the red, the green, and the blue, this one. Now look at their motion. Okay, look at carefully up to the end. Again once, look carefully. From this simulation, which car, red, green, or blue, are undergoing an acceleration? Or which car do you think that undergoing acceleration or accelerated? The blue, the red, or the green? The blue, the first one, the green, the second one, and the blue, the last, this one. Okay, if you see their movement, the green and the blue cars speeding up. The blue and the green, look, blue, look, and it's very fast, it's accelerating. Again, if you see the middle, the green one, look at At the end, it ahead red, the red car. That means the blue and the red cars are speeding up. Look carefully the simulation. That means, and let me ask you another question. Which car experiences the greatest acceleration? Which do you think has the greatest acceleration? Look, from the three cars. Which one? That means which one is accelerating? Okay, look, the blue one is accelerating or speeding up compared to the green one. Okay, that's about the simulation. Let's come to our lesson. All right, now the other point, acceleration is a vector physical quantity in the same direction as the change in velocity, because velocity also a vector physical quantity. So the acceleration is the same direction to the change in velocity, and it can either in magnitude or direction. Acceleration therefore change either speed or direction or both, we can say. When an object slows down, look, when an object slows down, that means the speed is decreasing, its acceleration is opposite to the direction of its motion. Such motion we call it deceleration. Deceleration. That means, for example, a car moving, let's say 10 meter per second, and when the driver brakes, or that means the car automatically stops. When it stops, its speed gradually changes to zero. That means decreasing. Such kind of motion we call it deceleration. Deceleration always refers to acceleration in the direction opposite to the direction of the velocity. That means if the car moves forward and forward towards, let's say forward, and when it stops, the deceleration always, that means the deceleration always towards what, opposite to the acceleration, towards or its velocity. That means deceleration always reduces the speed. Now here we have another simulation. Show the simulation. Let me show you another simulation about deceleration. Okay, look at this object, and look, it starts from here. It's speed up, then here slowing down, and this slowing down indicates there is a deceleration. Let's look again. Look, the object here, it's accelerating down, then in decreasing velocity, then finally here we have a slow velocity. Such kind of motion is a deceleration. You see, it's increasing then decreasing, because it's from up to down, its speed is decreasing. Such kind of simulation we'll see in the future. Okay, so you will see the change slowing down, this type of motion around this point. At this point, it's deceleration. Okay, thank you. Let's see the other part. Okay, let us look at the following example. This example 1. A recurse coming out of the gate accelerates from rest to a velocity of 15 meters per second due to west. Look the direction, in 1.8 seconds. What is the average acceleration? Let's look. We have given, when you get problem. The first, take out the given. What's given? Accelerates from rest. If you see accelerates from rest, that means the initial velocity, rest means the initial velocity is 0. Okay, the word rest now. And to a velocity means its final velocity is equal to 15 meter per second due to waste, or we can write the v final is equal to negative 15 meter per second. We can write like this, or the negative sign here, the negative sign indicates the direction. That's why. So let me write in new slide. And you are required, what's required? What is the average acceleration? The average acceleration, you are required to find what the acceleration or the average acceleration is equal to how much. Good. Solution. Okay, you take out first the given, then the required, then solution. We know that the acceleration is the change in velocity per time, which is equal to v final minus v initial over t t final minus t initial. Already it's given, already t minus t initial is equal to, already we have in total, the total it's included 1.8 second. Here let me write here, t is equal to 1.8 second. Now substitute all the values. This implies the acceleration is equal to v final, already how much? It's 15 meter per second due to waste. We have to write like 15 meter per second over due to waste, and the time it's 1.8 second. 1.8 second, which is equal to 8.33 meter per second square towards waste. That is the solution for this example. Good. Let's see another example. What will be the acceleration of an object which moves with uniform velocity? That means, what do you mean by uniform velocity? Let me okay, you have given here uniform velocity. Let's say uniform velocity is equal to, means v final is equal to v initial. That means that velocity is uniform, they are equal. You are required the acceleration for this uniform velocity. In general, solution. The acceleration is given by v final minus v initial over time. But for uniform motion, V final is equal to V initial, because the velocity, there is no change in velocity. That means V final minus V initial is equal to 0 over T, which is equal to 0. So note that you can write around here. You can write here. Let me write here. Note. Write down this one. For uniform velocity, the acceleration is 0, because there is no change in velocity. Okay, good. Okay, if you have any question, please write down on the comment section and I will reply to you, and I will also do another video if it's not clear. Okay, now let me give you homework for the next time, and write the answer on the comment section again for this question. This one, the third question is your homework. Okay, your homework. A truck is moving with a constant velocity v is equal to 5 meters per second. The driver, this meter dot the power of -1 means in your in your mathematics it's already meter per second, it's down. The driver stops for diesel and the truck accelerates forward. After 20 seconds, the driver stops accelerating to maintain constant velocity v is equal to 25 meters per second. What is the truck's acceleration? This, please, if you are following me, write down on the comment section. Okay, the answers. Okay, thank you for today's lesson. So next time, see you in another lesson. Until then, bye bye.